everyone, myself Charan. I'm studying Sri Venkateshwara Engineering College. Subject COA. Topic Floating Point Representation and the IEEE Stats. Introduction to Floating Point Representation. Floating point representation is a way to encode real numbers in a format that can be represents a wide range of the values. It allows the representation of a large values and a small number of values by using a scientific notation like format. This method is not computing for the tasks that requires high permissions, such as scientific calculations and the graphic readers. Compounds of the floating point numbers. Floating point number consists of three main components: the sign, the exponent, and the significand. The sign indicates whether the number is in a positive or negative, while exponent determines the scale of the number, and the significand provides the actual precision of the number, representing the significant digits of the values. IEEE 754 stands for overview. Its stands is most widely adopted standard for the floating point representation in computer. It defines the various formats of the representing the floating point of the number, including single precious and double precious. These stands ensure consistency and accuracy in the numerical consumption across different computer systems. Single precious format. Single precious uses 32 bits to represent a floating point number, consisting of 1 bit for the sign, 8 bits for the exponent, and the 23 bits for the significand. This format allows the approximately 7 decimal digits of the precious and the range of the values from about 1.4 into 10 to the power of minus 45 to 3.4 into 10 to the power of 38. Single precious are used in the applications where memory efficiency is critically, such as in a graphical processor. Double precious format. Double precious format is a 64-bit for the representing allocating 1 bit of the sign, 11 bits of the exponent, and 52 bits of the significand. This format provides approximately 15 decimal digits of the precious and the much larger range value represented. Double precious is commonly used in the significant computing where the high accuracy is required. Special values. The IEEE 75 stands for defines special values such as a NaN, not a number, positive infinity, and the negative infinity. It is used for the represent the undefined or unrepresentable values as such as a result of the dividing by 0 by 0. Positive and negative infinity are used for the representing the flow conditions or limits in the calculation. Rounding models. Rounding models is in IEEE 754 determines how floating point numbers are rounding during the arithmetic operations. The standard specifies several rounding modes included round in the nearest round towards the 0, that round towards the positive or negative infinity. The choice of the rounding modes efficiently affect result, especially in integrated algorithms. Precision and accuracy. Float point represents the inheritance involves trades off between precious and range of the values. Errors can accumulate in calculations due to loading, leading, and the precious loss, commonly referred as the load point errors. Floating point errors. Understanding the limitations of the floating point arithmetic is essential for the developer to avoid the critical applications of the float point. It represents an extensive used in the various fields, including the graphics, significant, simultaneous, and financial calculations. It enables the real time in the computer graphics and simultaneously the complex physics system in the science. The ability to handle the vast range of the values make it essential for the developing the robust and the efficiency software applications. Conclusion: IEEE stands for the Floating Point